right, the music stopped. I guess that means we're good to go. Hopefully everyone's reInvent has been going splendidly to this point. Everyone's looking forward to replay tonight. I promise we're not going to go too long. We're not going to keep you between, learning and drinks. I know where the priorities will come for most people, but, don't want to impart upon you my own beliefs or anything like that. So yeah, let's get started. Start learning what's new with database migrations. My name is John Winford. I'm a senior manager in the database services organization. I've been with AWS for many years. If any of you have been to reInvent in like the past 7 or 8 years, you've probably seen me around. I am joined today by Ryan, or not Ryan, in case that's not obvious. That is not Ryan. So why don't you introduce yourself for a sec?
Thank you, John. Hello, everyone. This is Vijay Karumaji. I'm a principal database solutions architect, mainly focused on RDS, Aurora, and DMS. Nice to meet you, everyone.
So Vijay will come back a bit later. In case you're wondering, it's bound to happen. You may have seen it a couple of times. Ryan came down with you-know-what on the way here and has spent his entire week at Vegas in a hotel room. So I don't envy him at all. Certainly great to have Vijay here helping out with the sessions. So I'm sure you'll enjoy it as we get into it, and we'll make good progress. So what are we going to talk about today? Quick agenda. Why migrate? No, we're good? Okay, why migrate? We don't migrate just for the sake of it. I don't personally consider it a fun thing to do. If that's how you spend your spare time, that's totally fine. But generally speaking, there's some typical reasons why people and companies consider migrating, and we'll go into that briefly. This isn't a sales pitch. We'll give you the true technical reasons why people tend to migrate and go into that. We'll do a bit of an overview of a typical customer migration journey, talk a little bit about modernization. There's a lot of commonalities in the migration process, and it's best you sort of understand what these are, because if somebody has encountered it before, it's best you can learn from that. For those that are new to DMS, we'll give a brief overview of the services and the different components. We're going to go over this fairly quickly, though, as we don't want to spend too much time on it. Overall, what we're here to do today is speak about what's new. I totally appreciate there's more than 200 AWS services, and it's hard to keep on top of what's been happening with each of these. So we're going to go into a pretty dense but comprehensive summary about what's changed in the database migration service from last year and how that can be useful to yourself, your company, and helping with migration, modernization, replication, data marts, data warehouses, all that sort of fun stuff. And because I know that probably by this point, Thursday, you've seen a lot of these breakout sessions. Death by PowerPoint is not something that I think most people enjoy. We are going to spend some time doing a couple of different product demos at the end, so you can see how some of these new features and functionalities work, and give you an idea of how you can actually use the product. All right. I just don't think anybody's ever said it, but our primary objective with DMS here is to make it as simple and straightforward as possible to do a migration. Migrations can be challenging. They don't have to be. As I mentioned before, we've tried to learn from what customers have seen in the past. We've spent a lot of time and effort on iterating and improving our product. The overall objective is to make it as straightforward as possible and as seamless as possible, because migration is not what's going to differentiate your business. Adding the value on top of your databases and creating a product that's saleable to the market is really what you're after, not migrations. So you may have seen this slide before. Overall, it's a fairly generic slide we use in the databases world at AWS. Overall, why are people migrating? As I said, that quote earlier, migrations are fun, that's not the justification for doing it, right? There's more to it than that. People tend to start their migrations, especially if they're new to the whole cloud adoption thing, starting with the simple ones. They do a lift and shift to EC2. What does that mean? You take your on-premises database, you put it on EC2, and you operate it much in the same way you did previously. Yes, there's some features that EC2 gives you. You've got the power of AWS. You can choose your instance type. It's a whole lot faster to get an EC2 instance going than it is to go purchase, acquire, provision, install the operating system, what have you, in the same way you would have traditionally done it in a data center. But this gets you going. You start to see some benefits, some reductions in costs, and increases in innovation. From here, people tend to move into managed databases. Costs are further reduced here. and the velocity of innovation continues to accelerate. But the cost change when you go to manage database isn't necessarily hardware related. If you've been in EC2 and you're going to RDS, there's still the underlying AWS costs, because we have infrastructure as well in there. Where you're starting to see the savings isn't on the infrastructure, but in the people capital. You're spending less time maintaining, monitoring, patching, all of this stuff you typically would have to do with a server. You don't have to do it anymore because the managed service is taking care of it. Backups. Backups are now done with a click of a mouse rather than, running your backup software, monitoring it, offloading it to, well, people don't use tape anymore, but, it makes it a whole lot easier when it's a managed service. Where people start to see the greatest savings and the highest velocity of innovation is when you start adopting cloud-native databases like Aurora and DynamoDB. You're breaking up that monolith. You no longer have this giant Oracle, SQL Server, whatever it is, database, and you're moving to a microservice architecture that lets you innovate and operate on individual components simultaneously without the dependencies that you would if it was a monolithic application. So, typical database modernization journey. Most modernization journeys start here with a relational database. Not always, but most of the time. It isn't just a story of those monolithic databases I was mentioning earlier. They do lack agility, they can be hard to scale, there's a variety of access patterns all crammed into that relational database model. That's not it though. It's also the story of startups and highly agile teams that are looking to, they were trying to get to market quickly. They were like, well, we don't really care about the database, we just need a place to put stuff. Let's just grab the first relational database we can find and shove it all in there. They might have leveraged an abstraction layer like an ORM. The entire objective of there is like, okay, it's not the focus, let's just use it. And then what happens, that startup is successful, it grows, they need to scale, and they go, oh geez, we really made some poor architectural decisions earlier. We probably shouldn't have shoved everything into that database of choice, insert whatever flavor you want. There comes a time when all of these things need to be modernized. The monoliths, the startup databases that grew, and whatever other scenario. All right, now let's wind it back. I want to be clear, for most of the session today, when I say database, I actually also mean data warehouse. It's called the database migration service. Could have called it the data warehouse migration service. It depends on your scenario. We treat all types of data equally. Database migrations are not always straightforward. We talked about the lift and shift. This is going to your EC2 platform. We talked about move to managed. This is going to a managed service like RDS or optionally something like Aurora or Dynamo. And then actually Dynamo is more of an example of modernized. So when you're going to sort of a cloud native platform. Depending on the path you go with, the tools you use to get there might vary. We're going to drill into the different parts of migration. Overall, though, let's just have a look at it. When you're migrating a database, it sounds easy, like, yeah, just move that. But a database has a couple different components to it. You've got the data in the database, and then you've also got the schema that forms the structure of the database. So if you're looking to migrate from, just for argument's sake, a SQL Server system to an Aurora MySQL box or database engine, you've got to worry about actually converting that schema from something that is SQL Server native to Aurora native, right? So there's some conversion part in there. And then after that, you then go and migrate the data. But a database doesn't exist in isolation. It's probably being used by other things, right? It's being used by applications. These applications would also need to be updated to use the new database engine of choice, whatever that is. So there's all of these different components that you've got to factor in when doing the actual migration. And although there's this stereotypical image of IT operating in the dark basement of an office building somewhere, the fact is we're all doing this to support a business. And you've got to think about those business users. So if you're going to do a migration, you can't say, oh, by the way, I'm going to take this super important system that you use offline for the next, 3-4 weeks while I'm doing this. That's not really feasible, right? So you've got to figure out a way to do that migration without impacting your end users to make it as seamless as possible for them. And then all of that, well, before you even get started, do you even know what you have? I know this sounds like a bit of a funny question. You go, oh, of course I know what I have. Believe me, I've worked with so many different companies that have grown hugely over the years, and they've got hundreds, if not thousands, of databases squirreled away. I mean, I've seen examples of databases that have just been running away on some literal desktop machine shoved under a desk in a corner somewhere, right? So, before you're going to start this journey, especially if you're trying to get out of a data center, you better know what you have because, you may be surprised. Thankfully, at AWS, we have you covered as much as we can. So how can we help you across that journey? The first set of items are the tools, right? These are the self-service tool sets. We'll talk a little bit today about AWS DMS Fleet Advisor. So Fleet Advisor is a component of DMS. It's geared toward customers that are looking to move a fleet of databases to the cloud. If you just have, 1, 5, 10, you're probably not going to use this capability. But the overall idea is that it will inventory what you've got and give you some information about it so that you can make an appropriate migration plan and really decide, where to start, where to go, and how to make those first steps. Fleet Advisor is a fairly high-level analysis. It will go, and as I said, I'll talk about it a bit later, but it'll go and find those databases for you. Some of those databases are going to be, your options are going to be limited, is maybe the best way to put it. If you've got a packaged application that is certified to work on Oracle, you can't just move that to Dynamo. It's not going to work. So for those, you don't really need to do a huge amount of analysis. You know that you need to take that Oracle database on premises and either move it to Oracle on EC2 or RDS for Oracle. You don't need to do a whole lot more than that. But for those databases that, generally speaking, you've probably developed in-house, you've got an in-house application that leverages a database, if you want to consider getting away from a commercial system to a cloud native or open source system, you can use the schema conversion tool to do an analysis of that database and give you an idea how easy or hard it might be to do that conversion. We'll talk a little bit more about that in a while. Just got to scroll down here to make sure I'm covering all the points. I know that's fun. That's the wrong button, obviously. 2 secs. Nope. That is fun. All right, got to use the mouse. All right, so then talking about the other tool, there is, of course, DMS. Probably didn't even need to look at my notes. DMS is, like I said, the product that actually moves the data from point A to point B. We'll go into DMS in a lot more information or detail soon. It is primarily used for database migration, like it's called, but we'll talk about some other use cases later on. There are people that use DMS in an ongoing basis, generally speaking for feeding data marts, data warehouses, extracting information to S3 to do any number of operations on it. Then we get into the people side of things. There just is an army of people at Amazon that can help you. We've got solution architects, we've got professional services, and of course we've got a massive partner network. Partners that are experts in doing this sort of thing probably operate, in your hometown, whatever that is. There's partners all around the world that are certified in database migrations that can give you a hand. And then, of course, we have a small specialized team inside Amazon as part of the Amazon Database Migration Accelerator. These people can come in, help create a migration plan, generate what we call a solution document, giving you a recommendation on the steps you should take and the potential target for your migration to either allow you to get started with a step-by-step, like these are the exact stages you should take for your migration, or help you get connected with a partner or ProServe to go further. On top of this, we have programs. Programs generally include things like MAP. MAP is targeted towards customers doing mass migrations, not just of databases, but of just their wholesale footprint to the cloud. Database Freedom is zeroed right in on how we can make that database migration easier for you. And if you need some hands-on training to actually understand how to do these migrations yourself, Data Labs are a great way to go about doing that as well. If you haven't heard about the Data Lab program, highly recommend you take a look. All right, so we are mainly here today to talk about DMS. As I mentioned, DMS focuses on migrating your data from one database to another. It supports a wide variety of sources and targets, both relational and non-relational, just to give you that flexibility. If you want to take something from, say, a Postgres system to Dynamo, DMS can help do that. If you wanted to go from a OLTP to a data warehouse system, again, it can help here. It really is what we like to call a bit of a Swiss Army knife. You go from source A to target B whatever that may be, DMS can help you with that. People can also use it to migrate from on-premises to EC2, from EC2 to RDS, from RDS back to EC2, or, for argument's sake, from RDS back to on-premises. It really does let you move your data from anywhere to anywhere else. It doesn't really discriminate, if you will. It's all about giving that flexibility and choice on where to migrate. Another strength of the migration service is that it does keep things operational while you are migrating. It is what we would actually call a logical replication product. What that means is we are reading the transaction logs of your source system to monitor for any changes during a migration. So it means that you can keep using your database however it is you want to, reading, writing, it doesn't matter, and we'll replicate those sources, or that information from the source to the target. And it is in that vein that people actually have realized that DMS is useful for a lot more than just a database migration. You can use it almost as a quasi-ETL tool, if you will, and people use it for other purposes like even moving data between regions at AWS. So there's a lot of flexibility there. Don't let the name fool you. It is a data movement product focusing on databases from point A to point B. And probably one of its strongest benefits, shall you say, is its cost. If you've gone out there and looked at the commercial market for migration and replication tools, they are not cheap. For us, DMS is something that is more of an enabler than anything else. We want you to use it to get you migrating to the cloud and have you leverage the products in the cloud the best way you possibly can. So we try to make it as economical as possible. We're really just covering the infrastructure costs for the most part, so that you don't leave that replication server running for 27 weeks when you really only needed it for 5 minutes. That's the general idea. It's a very economical service, letting you move your data around both into and out of the cloud, whatever works best for you. It's obviously, you know what? They didn't give me the new deck. This number's wrong. We have now migrated 800,000 databases using DMS. Well, more than 800,000. So there's lots of customers that have leveraged the product successfully. It's, as I said, very straightforward to use. And it's important also to highlight that last phrase, using DMS. This is certainly not the number of databases migrated into AWS. There are lots of other ways you can migrate. You can use your native technologies, right? So you could do a backup restore. You could use a third-party product from any number of vendors to do your migration. This is just 800,000 plus databases migrated using DMS. I'm a little worried now that I see that because there could be one slide missing coming up, but we'll see. We'll see. Nothing like thinking on your feet. DMS supports a wide range of sources and targets. It's a big number. Now, I admit this slide is slightly misleading because in some cases we use the schema conversion tool for data movement. And what I mean by that is specifically in the data warehouse space, data warehouses generally don't have a transaction or replication stream. What that means is you can't feed changes from, say, I don't know, just pick one of those data warehouses to a target. It's more of a batch and load type thing. So with the data warehouses, we have SCT uses what we call an extractor agent that lives close to that data warehouse that'll dump all the data out, shove it to S3, and then get it ingested into Redshift. So between DMS and SCT, those are the sources and targets we support. Please don't ask a question at the end about a specific version of a specific database on there, because I am not going to remember which one we support. But I can tell you that we strive to support as many of them as possible. We support quite a number of older versions. Generally speaking, there is a cohort of people that are migrating from unsupported platforms to something new. So of course, we try to support as many old versions as possible. What you will find is we may not support the absolute latest, greatest version of Database X that was released last week. Because again, we're a migration service. If you have just upgraded to the latest version of a database, you're probably not looking at migrating off at the very next week. So, we'll get there, but maybe give us a few months. All right, on to the next. Fleet Advisor. I talked a little bit about this earlier. DMS Fleet Advisor was a capability we launched at reInvent last year. It's geared towards customers that are running large fleets of databases who need the full picture of everything they have. It's a free discovery tool. So there's different components of DMS. The Fleet Advisor bit is no charge at all to run it. It helps you understand your databases and your environment. It provides functionality to discover and collect an inventory of running databases, such as your Oracle or SQL Server databases and others. Once it's collected all this information, you can look at it, you can organize it by database version, operating system, database size, number of tables, and so on and so forth, and use this information to feed a business case that you can use to decide whether or not to move forward with the migration. It's the level of analysis that it does, it's a lot more detailed than, say, a general server discovery. You know, it does more than tell you, oh, great, I found a server that's got a database on it. It will tell you the database that you've got, the version that's on there, whether or not it's still in support, for example, whether it's out of support. It'll tell you the number of schemas that are in that database. It'll tell you the number of objects in that schema, so how many tables, how many procedures, that sort of thing. And the other interesting capability that it has is it will tell you if it's identified any similar schemas elsewhere in your estate. So this is a pretty common. You've got dev, test, prod instances, right? If you're looking at doing a migration, do you really want to do it 3 times? You probably want to do it once, right? So Fleet Advisor will let you narrow that down and go, well, it says I have 1,000 servers, but because of dev, test, prod, I really only have 300, for argument's sake, right? So it's a high-level, broad brush environment to help, or capability to help you find your databases. Schema conversion tool. Now, this is the next level of analysis. Its overall objective is to help you convert your commercial database and data warehouse schemas to open source engines or AWS native services, such as Aurora or Redshift. It works in conjunction with DMS. So remember, you know, DMS moves the data, SCT converts the schema, and generally speaking, you're going to use it for that heterogeneous case. It does 3 main things. It helps run, or not helps, it runs an automated migration assessment report. So it connects to the source and does a deep analysis of it and gives you a summary of how much it can convert automatically to another database engine. So say you do an analysis of an Oracle database, it's going to say I can convert, I don't know, 92% automatically to Postgres, or I can convert only 87% if I went to MySQL. Now, you might be wondering what's the difference between this and Fleet Advisor. Fleet Advisor is like that high-level analysis. As I said, it'll tell you the number of databases, the types, and the objects in there, but it's not going to say, we recommend you go to this because we've done this in-depth evaluation of it, and this is sort of what we say. It's more like, this is what we've got, and if there is something that you think is a candidate for refactoring to a modernized platform, then you would run SCT on it. The other reason for that is Fleet Advisor is meant to run in an ongoing basis and sort of monitor usage metrics and that sort of thing. It also runs very quickly. If you ran SCT against 1,000 databases in your estate, nothing to say you couldn't do it, but that could take a long time to run. An SCT analysis per database usually takes anywhere from, for really small ones, it'll be done in like 30 seconds. But we have seen some very complicated schemas containing tens of thousands of procedures and tables and packages and whatever else that SCT will actually run overnight for, right? So you don't necessarily want to do that in-depth analysis on 1,000 databases in your estate all at once. The other thing it'll do, it will help convert it, right? So we do the assessment, and then if this looks good to you and you want to give it a shot, it'll convert that schema from whatever it was to whatever new modern target you're looking at. Now, does it get 100% conversion? Only in demos. Oh, wait, did I say that out loud? No, like it actually does a really good job. There are cases where you will get 100% conversion if you haven't done anything super complex or crazy in there. Generally speaking, we've done a pretty thorough job of emulating capability from a source to target. So say, for example, Postgres doesn't have a function that is in Oracle. With SCT, we'll either convert it automatically or possibly we'll use this thing we call an extension pack where we'll emulate that function in Postgres. So overall, we get the conversion actually pretty good. And it gets better every month. We release a new version every month of SCT and really try to make it as close to automated as possible. But for full transparency, it's not click button done, right? You got to spend a bit of time evaluating it. And the other thing it does, is it will also help convert application code. So if you have a homegrown app that you've got a bunch of SQL statements embedded in that app, it will go scan through that app code and try to convert, I don't know, for argument's sake, the T-SQL to PL/SQL in there. Now, if your SQL statements are highly dynamic in nature, you've built them up through concatenations and whatever else, well, it's probably not going to do the best job there. But honestly, I've seen a lot of code. A lot of people just, have a SQL file with all the statements in there, and it'll help convert them for you. And as I mentioned earlier, in the data warehouse space, it will actually also migrate the data. So again, it's just a little bit different. Data warehousing tends to be moved with SCT. OLTP tends to be moved with DMS. Use cases. DMS can help you modernize, migrate, and replicate for any or all of your data needs. Modernizing, we've talked a lot about that. That's converting from one database engine to another and update the application code. Migrating, well, you're looking to move data from A to B. As I said, that can be between NoSQL to SQL, SQL to SQL, on-premises, whatever. The general idea is you're moving data. Examples of this, people are migrating business-critical applications. They're taking a data warehouse to Redshift. Another interesting one is upgrading minor and major versions of a database. So say RDS. RDS is great. If you want to go from version A to version B of a database, you go into the console, you flip the versions, you say apply during my next maintenance window, and it'll apply those changes, and you'll end up presto changeo with the new database version. There are some features they've either released or releasing soon to make that a bit simpler, but it doesn't. For some database engines, we've had some customers use DMS to make it a bit more seamless. What do I mean by that? If customers can't handle that outage during the maintenance window of having that database updated, what they'll do is they'll spin up the new version of that database engine, whatever it is, and then they've got their existing production version with the old version, so to speak, and they'll use DMS to replicate the data between the two RDS instances. Because then, when you want to upgrade, like when you want to flip that switch and use the newest version, the only outage you need to take is however long it takes you to update the pointers for your application to point to the new database. So generally speaking, that's a DNS update, happens in seconds, if not milliseconds, depending on the scenario. So people do use it for that. Other things, people will consolidate shards. If you've got a big sharded system and you don't need to shard anymore with things like Aurora, you can use it to consolidate that. Of course, you could go the other way, right? So people have a big monolith. They want to break things into microservices. DMS, again, because it's a logical replication product, you can take table A, move it to Aurora. You can take table B, move it to Dynamo, table C, move it to Redshift. Whatever makes sense, it doesn't really care. You don't need to move the whole database. You can move parts of it, including just the rows if you wanted to. So you can filter down on the rows as well. Other things people do is they'll migrate data either from or to S3. So if you want to take things out of a system and maybe archive off old data and put it in S3 because it's a lot cheaper to have it there than it is in an online database, you can use DMS to do that as well. Oh, new since last year. That's why we're all here, isn't it? To find out what is new. There's been a lot that's changed since last year. This actually probably isn't a totally complete list. Of course, there's been lots of patching and security fixes and all that sort of fun stuff as well. But overall, this at a high level is what we've done. Babelfish was announced at reInvent last year. We added Babelfish as a target shortly thereafter. So now if you want to migrate to Babelfish, you can do so with DMS. DB2 mainframe. So we've had DB2 LUW for some time now. That's Linux, Unix, Windows, if you hadn't heard that phrase before. We also added support for DB2 on Z or Z, depending on your language of choice, which was the next logical step. There's more to come here as well. We added support for SQL Server read replicas. So now you can take the load. Actually, I should actually go into detail on this one a bit. DMS isn't magic, right? Remember I was saying it's a logical replication product? We have to read from those logs. That does add some load onto the database server. So if your database server is absolutely pegged and you try to throw another DMS task on top of it, it might cause some challenges. So for SQL Server customers, the ability to read from the read replica instead of the primary was a very useful feature that we added last year. We also added support for VPC endpoints. If you didn't know, a VPC endpoint enables creation of a private connection between a VPC and supported AWS services, so you don't need public IPs and that sort of thing. Pre-flight enhancements, what that means is optionally you can run some checks before your migration begins to ensure that it's going to be successful. There's nothing worse than, say you're migrating some giant database, you get through the first 100 tables, and on the 101st table it fails. It fails because of some unsupported data type or who knows what else. So the pre-flight enhancements, we've just put a lot more checks in there to ensure that your migration is going to be successful before you hit the go button. We've got some enhanced logging. Going back to that initial statement about migrations are fun, one of the reasons they can be frustrating is you encounter some obscure error as you get through the process. There's all sorts of things that can go wrong, and I'm certainly not trying to scare you off, but there could be problems with the drivers, there could be problems with permissions, there could be problems with your network, it could be that the database server is overloaded, et cetera, et cetera. So we've tried to make that a lot more straightforward with some enhanced logging to make it a little bit more obvious what the problem was if you encounter it. And we've given you the ability to offload those logs to S3 so that if you do need to share it with us or a partner or what have you, you can go through those logs and remove any PII information that maybe you don't want to share. We've added new operating system beneath the scenes. AL2, if you haven't heard that phrase, that stands for Amazon Linux 2. Behind the scenes, DMS is just running on an EC2 server like almost everything else out there. We upgraded to the latest and greatest version of AL2 to ensure all the security fixes are there, and we support Gen 6 instances now for replication. We also added support for IPv6, pretty much a given these days. It just took a little bit of time to get there, so you can use IPv6 if you want. And then in the SCT space, we can now do an assessment for Babelfish. So you can do an analysis of your SQL Server system and say, hey, what kind of compatibility are you going to get if you move to Babelfish? In case anybody has looked at Babelfish before and are wondering what's the difference between SCT and the Babelfish tool called Compass, not a whole lot. Compass is maybe actually a little bit closer to whatever the current version of Babelfish is, purely because it's developed by the Babelfish team. We might be, a few weeks, maybe a month behind on the assessment. But if you're used to using SCT, we just kind of feel it's good to keep everything in the same place. We support schema conversion from Snowflake now, as well as Azure, and we added support for Amazon Redshift Serverless. Google BigQuery also got added in, and then we've added support for actually ETL conversion from SQL Server Integration Services to Glue Studio. So again, I'm not the Glue guy here, but there's Glue and there's Glue Studio. We're starting to add Glue Studio as a target for a lot of the conversions for ETL. We've also got an Informatica redirector. What does that mean? For people that are going to or like to continue using Informatica, may have a huge Informatica estate, been using it for lots of ETL in the past. Traditionally, maybe that ETL has directed things to a Teradata warehouse, for example, or Netezza or Greenplum, any other data warehouse of choice. This now allows you to go in and automatically update and edit your Informatica scripts to point to Redshift instead of your legacy data warehouse. Improved code conversion. We now are better at recognizing C# and Java code and updating the SQL statements in there in a way that we didn't before, just to make that conversion simpler. All right, product integration. There are a wide variety of tools one can use during migration. And, I didn't say this at the start. This may sound odd. I don't really mind what tools you use. At AWS, we just want you to migrate. If DMS, SCT, what have you, aren't the right tools for you, use something else. That's totally fine. You may have a license for a big commercial replication product. It's totally fine if you keep using that. But we're here to make it as simple as possible to do that migration. That wide variety can be a bit confusing. Sometimes the use case for each tool overlaps. Sometimes it's not clear if one tool might deliver a better result than another. And the user experience can also be confusing as you transition between different tools at different phases of a migration. I mentioned it last year. We started resolving this by launching DMS Fleet Advisor, which is integrated into DMS, right? So you start your migration journey by finding your databases, and then you start migrating them inside the same console. Now, there are other products out there at AWS to discover things, right? And we are working towards, providing a seamless experience with those as well. But really, we're giving you the choice if you're looking at doing a database modernization versus an all-up estate migration. We're trying to make this as seamless and straightforward as possible. Yes, we talked a little bit about Fleet Advisor. As I said, we're trying to minimize the example of a disjointed workflow. And as I said, at reInvent last year, we launched Fleet Advisor embedded in the DMS console. Now, this isn't quite what the DMS console looks like today. It's a screenshot of how it looked last year. That little toggle for DMS Studio is no longer there, but you get the general idea. You can start with Fleet Advisor at the top and then move down to data migration as you proceed along. That's not it, though. We're not done. The big announcement that came out on Sunday was we just announced schema conversion as part of DMS. So we're calling that AWS DMS schema conversion. Some things are just better when you do them all together. So the general idea is now you can use DMS as a central location to plan, discover your databases, do an assessment, then migrate and modernize them, and AWS schema conversion, or AWS DMS schema conversion just makes it intuitive and simpler to go from one phase to the next. What does it do? Well, today, in full disclaimer, this is a V1. You can convert Oracle and SQL Server database schemas to MySQL and Postgres targets. As with the standalone SCT desktop tool, you start by establishing a connection to your database and then running the assessment report. Now, again, we talked about the differences between what SCT does and what Fleet Advisor does. So this is that more detailed analysis you can do in there. Now, what are the benefits of a service? Well, we talked about the integration. Flows from one section to the next pretty seamlessly. The other thing is you don't need any extra security evaluations done by your internal IT department. So the schema conversion tool, in case it wasn't obvious from the name or you haven't used it before, it's kind of an anomaly in Amazon land. It is a downloadable, standalone Java product. So you download this Java tool, you put it either on your database server, near your database server, on your laptop, whatever, and then you run the assessment and you can do the conversion locally. That made sense 7 years ago or so when we launched it. People were hesitant about the cloud. They weren't really sure what it was all about. Now, people are like, what's this thing? I got to talk to IT. I don't have admin privileges on my laptop, or they don't let us install apps without a thorough analysis. So it makes a lot more sense for us to now put that schema conversion embedded into the web service in the cloud. You don't need any extra admin permissions. And on top of that, you have the power of AWS behind there. So you may have heard me mention earlier that some complex schemas can take a long time to run. Well, now, instead of having that compute power local on your laptop, you've got the power of EC2 behind schema conversion doing that analysis. Probably one of the best things about it is that, again, like Fleet Advisor, it's free. So you don't have to pay for anything with SCT or with schema conversion embedded inside DMS. But, full disclaimer, this is a V1 product. We don't have all the same capabilities as the schema conversion tool today. So we support only that limited subset of databases, and we don't do app conversion or inline code editing or ETL just yet. But, as with time, this stuff will come. So I think it's probably time that we do a bit of a, demo. So I'm going to switch over. Hopefully this works. Just a second. All right. Hey, look at that. Isn't technology grand? Now, I would have done a live demo. I personally love doing live demos, but best practices are saying no. Don't do the live demos in case you have Wi-Fi problems or something like that. So you get me talking to a video that I recorded earlier. So here's what schema conversion looks like inside DMS. You've got this new menu there called Convert that has these three options: migration projects, instance profiles, and data providers. Obviously, migration projects are what we're talking about. It's a project that we're going to use to migrate. The instance profiles, well, we'll dive into that in a minute. These are just common security and settings that you would use across all of the different projects that you might have. And then data providers, well, this is just the information about the source in the target database. Where is it? What's the username? What's the password? That sort of stuff. And And what you'll see as time goes on is we start leveraging these sort of concepts a little bit more through the entire migration journey. So we'll go in and create a new instance profile. Obvious things you do is you give it a name, right? What kind of IP address you want to use. As I said, the IPv6 stuff's there. It's very standard Amazon. Which VPC do you want the schema conversion to be running in? Which subnets to use? And you can add some extra settings. Now, in here, this is where we're going to be saving the migration project. We save it in an S3 bucket. It's not like we're saving it to disk or anything like that. And then the permissions, or the IAM role rather, that has permissions to access that S3 bucket. Other things we can do, well, we'll create that instance profile just now. We'll come back to some of the more details. So we've now got 2 instance profiles in this case. I would imagine most people are probably just going to have one. But then the next steps are to go and create a data provider. And again, remember that data provider is just the connection to the database. So we're going to create a new one. In this case, we're going to connect to a SQL Server system. You can give it a description or ARN if you want. Standard things, server name, password, username. You can see in this case, we're obviously using a resource that is in AWS. Well, that's just because when we're building the demos, I don't have access to an on-premises system, but you could put the IP address of an on-premises system in there, and it's going to work just the same. So we're going to choose the RDS one. In this case, this is your MySQL target, right? So we're going from SQL to MySQL right here. SSL is generally a good thing to use, but again, for demo purposes, we haven't set this up. Yeah, then from there we go and we create a migration project. So just give it a name as an example. There's this instance profile again. So these are the VPCs that you're going to use and the security permissions and that sort of thing. And now you say what we're migrating from. This is the SQL Server system. What secrets manager ID we want to use to connect to that SQL Server system. So you have to put the username and password inside AWS Secrets Manager. And then also we're going from one to another. So what are we going to migrate to? In this case, we're going to migrate to MySQL. You can choose a different secrets ID if it is different. I would assume the username and password would be different between your source and your target. And then the permissions to use to access that secret manager. And optionally in here, you can add a transformation. So this kind of transformation, if you know some of the differences between, say, Oracle and Postgres, one's case sensitive, one's not. So you can say, move everything to lowercase, for example. So that's what's happening here. Now that migration project is created, we need to actually launch the schema conversion. So right now, we've just kind of given schema conversion all the settings. We're going to launch an EC2 instance now that will do that analysis and conversion for you. Now, this is a demo. We've cut some time out. It can take a few minutes to launch that replication instance and do the analysis. So, just be patient. Once that's done, this brings up the IDE, let's say. Looks very similar to a lot of the IDEs. We've got the source on the left, the target on the right, and we're going to choose the database that we want to do an analysis on. In this case, we'll just choose that one at the top. Go in, and the very first thing you're generally going to do is run the assessment. So again, the assessment will take a minute or so to run, goes through, and eventually, again, sped up for demo purposes, you'll get the assessment report result here that tells you how much of it can be converted easily between your source and your target. You can browse down through the tree, and you can see each individual item if you want. You don't have to see it at a consolidated level. You can see it down for your given table or a procedure of choice, and just give you an idea of how easy or hard it's going to be to convert. Give it a second here. Different procedures, and you can drill into it a little bit more and see the original SQL on the left that that procedure was created with. At the end, if you want, you can export the assessment report either to CSV or PDF, and you can use it to, support a business case or say, hey, look, this is how much we can convert automatically. No, that's not supposed. Oh, there we go. Video is just a bit glitchy. Oh, there's the assessment report. Sorry, just white screen flickering. So this is the PDF copy of that assessment report that we were viewing on screen earlier. All right, once that's done, the next step, of course, is to convert the database. Now, you probably wouldn't do it quite this fast in real life, but for this demo, we're now going to go and convert. So what you'll see is all of the objects on the left are going to be converted to the right, which is now the MySQL system. You can see we've got some case differences between source and targets. The schema has been renamed a little bit. It no longer says DBO. It says, large db.dbo, and that was that transform we saw added earlier. And as you click into each object, you can see this is what the original SQL Server code looked like on the left, and the converted code is on the right in MySQL format. And it doesn't happen for just the tables, but you'll see in a second as we get down there, actually, it's just showing an example. Not everything will necessarily convert automatically, so when that happens, you can click into it and see why it didn't work. But then we'll go down and we'll look at some procedures, I believe. Just give it a second. Yeah, there we go. So it's just showing that one converted automatically. All right. And at this point now, we can apply the changes to the target. I guess I didn't show the procedure one in this case. So right now what's happening is that generated SQL, which is just in memory at this point, is now being applied to your target database. Up until this point, nothing has actually happened, but we've gone and applied it there. So now what you have on your target MySQL system is an empty database. Well, sorry. It's a database with an empty schema. There's no data in there at all at this point in time. So it'll take a couple seconds to apply. And you can also optionally take the SQL that was used to generate that schema and export it to S3 and view it if you want in a zip file. So you don't have to let schema conversion apply the schema to your target database. You can just take the generated results of it to a text file and apply it as you see fit manually as well. So that's always an option. And at the end, the result, you can see we're in dbeaver. If you haven't used dbeaver before, it's just more of a generic SQL query tool. You can connect to any number of different types of databases and data warehouses. You can see the converted objects are now there in the database, and you can see the size on the right-hand side there. You can see they're all empty, right? Just 16K of information defining the schema with no data in there whatsoever. And that, I think, is the end of that demo. Just switch back for a second. Let's hope for the best. I think it's that one. Hey, look at that. It works. I like it. All right, so overall, DMS is out there to make it easy to migrate. You're going to go from any source to any target. You can do the full load, which is the full set of data, or you can do the changes. So often a migration will have both that full initial set of data plus replicating the changes that are occurring while the migration is happening. Alternatively, you can just replicate the changes. Excuse me. As I said, we have a breadth of options, lots of different sources and targets to choose from. CDC allows uninterrupted use of your systems during the migrations. And overall, it has the benefit of being a managed service, right? So you don't have to worry about scaling, high availability, patching, monitoring security fixes, all of that stuff AWS handles for you. Overall, though, one of the biggest benefits of DMS, let's try it again, is automation, right? It is a managed service. With a managed service comes the ability to use things like CloudFormation templates to launch it. It gives you the ability to have other integrated services like CloudWatch events. And more than anything else, you have access to an API and a CLI to do whatever you want with this. I mean, we've seen examples of customers that have migrated thousands of databases. You know, they might be sort of an ISV, if you will, that has one database per customer. They want to migrate it all. Using the API, you can script that. So you migrate one database one night, another database the next, or 200 per night if you want. So that's one of the big benefits of being a managed service, is you get the full scripted ability to customize it however you want. One such example of how you can do automation is with EventBridge. So EventBridge is actually a pretty cool product. It's a serverless event bus service that lets you connect your applications with data from a variety of sources. EventBridge was formerly called Amazon CloudWatch Events. If you used it previously, it delivers a stream of real-time information from your applications, SaaS products, what have you, or AWS services to targets such as Lambda, HTTP invocation, endpoints using APIs, what have you. In this case, though, we're going to use EventBridge to provide a notification of when an AWS DMS event happens. You might use it, say somebody created a new replication instance, or the replication instance was shut down. But more likely what you're going to do is use it to highlight, say, if something happens. Does a task fail? Does a task pause? Does it stop? Does it resume? What have you? AWS DMS generates a lot of different events that you can use to make it easier to automate. So I'm going to get Vijay to come up and show an example of how this works in a demo, which actually ironically has started automatically. So let me just bring that back to start. So yeah, let's get going with a demo. Vijay, over to you.
Yeah, thank you. I want to go back to the presentation ones.
Nope, let's do that one.
Oh, that's where I am. So I think I need to go to 1 and then take. So I just have an architectural diagram that I want to cover. Oops.
Yep, there you go.
Yeah.
Perfect. Restart it.
Yeah, sorry guys. What I'm going to show as part of the architectural diagram, as John showed, right? Event bridge is, you can integrate event bridge with a DMS. So right now we don't have an architecture diagram, but what I put together for us is I have a DMS instance task in this case, so which is like MySQL to S3. I'm migrating data from MySQL to S3. MySQL is my source, and S3 is the target. So while I'm doing this migration, migrating the task, there is a failure happens, right? So I want to use event bridge to capture this event and then automatically try to fix this task. So for that, what I did is, as some of the prerequisites that MySQL requires for this migration is to enable binary logs for the MySQL. Everyone knows about MySQL, or you want me to give a quick overview? So if you want to do the migration from MySQL to any target, we need to enable binary logs. So that is the prerequisite was missing in our case. So what I'm going to do is I will capture the event, the failure event, and then take that into an event bridge. And then I created a rule in the event bridge, which I'm going to show you. Using that rule, I will match it to the target, which will call a Lambda function. Within that Lambda function, I have created a code. You can use it your own custom codes in Lambda function to fix any of those kind of failures. So with that, let's get started and see what really happens. So here, I have a MySQL to S3 task, and which is failed. So it is a full load with an ongoing task. And then as you see, the failure is, this is the event that you can see in the CloudWatch logs. So I just want to show you here, because for the MySQL to do the migration, we need a row format, right? So what I'm going to do is now I will show you my source, which is MySQL here. I'm going to connect to MySQL and then show you what is the row format of the binary logs. So I'm connecting to the source engine, and then I'm going to log into MySQL just to show you what's really happening here. Now I'm going to query the variable binary log format, and which shows mixed. So for us to do the ongoing replication from MySQL to S3 or any target, this needs to be a row format. So that was the problem. That is the reason we are getting the failure. So what I'm going to do is, now this is the event that got generated of that failure that you can see in the CloudWatch logs. So this is the event. As part of this event, what we have is the source here, which is AWS DMS, right? So I'm going to use that as part of my event bridge, and then event type, replication task failed. I'm going to use both of them and then going to fix this automatically for us. So you can do that for any of the replication tasks that you have. So this is just one example that I can show it quickly. So Now that you have seen that, what I'm going to do is I'm going to go to Event Bridge, and then I'm going to show the rule here. So in this rule, what we have is the source and then event type that I used it from the CloudWatch logs that we got, right? So the replication task failed. So I check the rule, and then I will forward that event to the target. So here you have multiple targets, right? You can send an SNS notification, you can send a Lambda function, depends on whatever you want to do, depends on the task, right? In this case, I'm fixing the MySQL prerequisite, but if you want to get notified when there is a task fails, you can send it to. So in this Lambda function, what I have is, if you see the CDC parameters prerequisites, right? So right now I'm taking the details and then detail message from the task. And then I'm going to check the prerequisite. So because my prerequisite was failing, so I have already configured within my Lambda function that are required for the prerequisites for MySQL as a source. And then what I'm going to do is I'm going to fix that to row. So it's already done in the Lambda function. And then I'm going to set that as a row, right? That's what this Lambda function does. And then I'm going to resume the task. Everything is going to be automated using this Lambda function. So right now what's happening is I'm going to enable this rule. Once I enable this rule, I'm going to start the task again. So right now, the rule is enabled. The rule is pointed to a specific target, which is my Lambda function. So what I'm going to do is I'm going to start the task again. So whenever I start the task, right, it is going to fail. Once it fails, my rule kicks in, and then I'm going to go to the Lambda function, and then it will automatically start the task again. So what happens right now, you see that it is running. I'm going to refresh it, and it is failed. Once it is failed, what will happen is now I'm going to go to the Lambda function. Within the Lambda function, what I have is I'm fixing my binary log formats, and then I'm going to start the task. So it should automatically fix the task. So if you see here, while that is happening, so my Lambda function must have kicked in, and then it changed my row format, right? Binary log format to row. So now my task have all the prerequisites that is required, and then tasks should run automatically. So if you see, it is rowed right now. And then if I refresh it, it is starting. And then load completed, and replication is ongoing. So this is how you can use the event bridge with DMS, right? It is a pretty good, cool feature that we have. So if you want to use this, right, you have to be at least minimum 3.4.6 or higher to use the event bridge. So now going back to the presentation, I think what we have is the resources that we have, right?
Yeah, so that's pretty much it. Apologies for lacking the architecture diagram. It probably would have made it a little bit clearer what was going on.
Yeah.
But when if you want to download the slides at the end of this presentation, when they get published on the website, I guarantee you there are going to be 2 changes in there. There's going to be an architecture diagram, and it's going to say 800,000 databases migrated. I don't know why that didn't make it through to this laptop, but these things happen. So hopefully that was interesting for everybody today. Here's some resources in case you want to get started with DMS. We're pretty much out of time. We'll be happy to take some questions at the sidebar afterwards if you want. But overall, hopefully that was interesting. Hopefully your week here in Las Vegas has been great, and everybody enjoys replay tonight. So thanks again, everyone.